Okay, in this video, I'm going to be going over section 3.2, which is really just all about kind of analyzing graphs of functions, determining whether a graph is a function or not, and then just talking about characteristics of graphs. So we're going to be identifying the graph of a function and learn how to obtain information from or about the graph of a function. So the first thing we're going to talk about is how to use the vertical line test to determine whether the graph of a function is a function or not. And this test tells us that if we look at a graph of a function and then we inspect a vertical line across every point of the function, if it only crosses our vertical line once, then it is a function, because then every x value only has one output. So, for example, we have these two graphs here, and you can see that they are putting a vertical line here on that graph, and it's only intersecting the graph once. And if I put a vertical line anywhere else, it'll only intersect it once. So A is a function. And the other one is also a function, because if I put this vertical line, it's only crossing once. If I put one here, it only crosses once. If I put one here, it only crosses once. So this one is also a function. Next example, the graph on the left, if I put a vertical line, it's crossing it twice. So this is not a function. And you can see here that these 2 points it's going through, my vertical line, has the same x value. So that x value, -2, has two outputs for y, 1 and -1. So it's not a function. Same thing on the right side. These two vertical lines are both crossing 2 points. And they share same x values. So these are not functions. Okay. All right, now we're going to talk about how to obtain information from a graph. So I have these questions here, A through G, and we're going to be using the graph on the right to answer them. So the first question says, what are f of 1, f of 0, and f of 4? So if you remember, f of 1 means what is the y value when x is equal to 1. So we look on our graph and find x equal to 1, and we see where our graph intersects at x equals 1. So here is x equals 1 on the x-axis, and if I drew a line up, it's connecting at that point there of 1, 2. So the y value there is equal to 2, and that's where it lines up. So that f of 1 is equal to 2. Let me put this here, and let me put this here. Okay, the next one is f of 0. So we find x equals 0. Use a different color here. And that point is right on x is 0 at the origin. That graph is crossing at that point. So the y value there is also equal to 0. And finally, f of 4. Find the value of 4 on the x-axis, which is there. And that corresponds with this point. And the y value there is -3. So this is equal to -3. Okay, next question says, what is the domain of f? Which again is all the x values. And this function, it's not going forever because it's ending at those endpoints. If it was, then my curve would look like this with arrows. That means it's going forever, but this is not. It's stopping. So if I look at this graph from left to right, the first x value I see is right here, -4. So my domain is going to start at -4 with a bracket because it's including it. And then it has all the x values up until 3. It's right here. So my domain is from -4 to 3 with a closed bracket. Because that one was also a closed point at the end there if I erase that green. That's the domain. The range, the smallest y value, if I go from bottom up, is that -3 here. So my range is going to start at -3, and then the largest y value I see is a +2. So my graph is only including these values for y, from -3 to 2. Next one says list the intercepts. So let's first start with the x-intercepts. So I have -3, 0, 0, 0, and 3, 0. Those are going to be my x-intercepts. And then my y-intercepts is just 0, 0. E, how many times does the line y equals -1 intersect the graph? So y equals -1. That line is going to be a horizontal line at -1 right here. So how many times does that line intersect my graph? Well, that's going to be 3 times. F, for what values of x does f of x equal -3? So now we're looking at the y value of -3, which is right here. And we're trying to determine what values of x does the function have a y value of -3. The only one that lines up with y is -3 is this point here. And that x value is 4. And I'll write it like this, actually. And then finally, G, what values of x is f of x greater than 0? So remember, f of x is the same thing as y. So for what values of x is the function greater than 0? Well, that's going to be anything that's above this axis. Okay, so any part of my graph that's above the x-axis, that's where y is greater than 0. So what values of x is that true? Well, we have this part of our graph that's above 0, and those x values are from -4 to -3. And then it's also above 0 right here on my graph, and that starts at x is 0 and ends at 3. And it is an interval because they are above 0 on all of those, in between 0 and 3, and in between -4 and -3. So that would be the answer for that. I do want to, well, that's fine. Okay. Okay, next one says, consider the function f of x is equal to x plus 3 over x plus 4. Find the domain. So again, to find the domain, we think about the restriction, and the restriction is we can't divide by 0. And the value that will make the denominator equal 0 is -4. So the domain is the set of all x such that x does not equal -4. B says, is the point 1, 3/4 on the graph of f? So to determine this, we're going to plug this in to our function. So 3/4 is y, so f of x is y, so this would be 3/4 is equal to 1 plus 3 over 1 plus 4. Just plugging these in to my values. 1 plus 3 is equal to 4 over 5, and this is not equal to 3/4. So no, the point 1 comma 3/4 is not on the graph, since I plugged that in and it wasn't an equal statement. All right, see, if x is equal to 2, what is f of x? So that's just telling us to plug 2 into the function for x. So this will give us 2 plus 3 over 2 plus 4, which is equal to 5, 6. And that point we just found is the point 2 comma 5, 6, since we plugged 2 in for x and we got a value for y as an output. Okay, we're still using this same function, and now we're going to answer D. So it says if f of x is equal to 4, what is x? So now it's saying y is equal to 4, so I'm going to plug 4 in for f of x. And to solve this, I will have to multiply both sides by x plus 4 to cancel it here. And on the left side, that'll give me 4x plus 16 is equal to x plus 3. Let me move this up a little bit. And so I'll subtract x to both sides to get 3x, and then I'll subtract 16. And then divide by 3, so x is equal to negative 13 over 3. And that point would be negative 13 over 3, comma 4, since we plugged 4 in for y, and then we got an answer for x. E, what are the x-intercepts of the graph, if any? So to find an x-intercept, we plug 0 in for y. And then, of course, we will have to multiply both sides by that x plus 4 again. So they'll cancel, but 0 times anything is 0. So we're left with 0 equals x plus 3. So therefore, x is equal to negative 3 is the value of the x-coordinate of our x-intercept. And that point is negative 3 comma 0, since we plugged 0 in for y and got a value for x. Okay, so now let's just talk about an application problem. So this one says the average cost, and you'll see a lot of these in your homework, I'm sure. They like to use this equation. The average cost C, so they'll use C of x to represent a function that represents the average cost per drone of manufacturing X drones. So now here they're telling me that X is equal to the number of drones per day. So X is equal to the number of drones per day is given by this crazy long function. Okay, and they're going to ask us to determine a couple things. The first one is determine the average cost of manufacturing 10 drones in a day. So then we're just going to let x equal 10, which is the same thing as finding C of 10. They're going to do this on the next slide. So to find C of 10, they just plug 10 in for all the x's. And then after simplifying all that, they get $1,940.20. Then B was to find the average cost of manufacturing 20 drones. So they plug 20 in to all the x's, and they get, this is their final answer, 1,220 cents. And so forth. I'm not going to go through all of those. You can compare. So D was wanting us to graph the function of the cost function for values of x that are between 0 and 60. And this is what the graph will look like. So let me go to my graph, clear, and let me see. Okay, I am going to type this graph into the calculator. So it was equal to 0.7x squared minus 45x plus 1320.2 plus a fraction, so I'm just going to put that in parentheses, 10,000 divided by x. Okay, I'm just going to hit graph, but I'm going to go to my window. So whenever it says to graph it for values of x between 0 and 60, I can set my x min to 0. I can even do -1 just to kind of show, but I'm just going to do 0. And then x max, I'll make it be 60. And the y min and max, I'm going to let the y min be 0 and then the y max be 20. Okay, let me go back to their graph here. So the y values are very, very large. So in order to be able to see this, we would really have to set our window for our y to a really large number. Let's try 1500 and put our scale to 50. Okay, now it's showing us, just to kind of show you that it matches. All right, so the reason why I'm really showing you this is for part E. So part E is asking us to, and let me go back to the actual question, to create a table with table start equals 1 and table equals 1, which value of x minimize the average cost. So I'm going to look at my table of values to find the value of x that gave me the smallest y value, since the y value is my average cost, minimized the average cost. So let's go back to this and go to second table. Okay, and we can see our table of values here. And we're looking for the smallest y value. So if I scroll down, it's getting smaller, and then it starts getting bigger. So let me go back up. Okay, it's not letting me. There we go. Okay, so you can see that we don't want to be looking at negative values because we're talking about cost and the number of drones they manufactured. So they're not going to manufacture the negative amount. So we're starting at 1 because it can't be 0 either. And so if we look at these values, it looks to be like they're decreasing, getting smaller, getting smaller, getting smaller, until we get to here where it starts increasing. So the smallest value I see is this one, 883. So that means the value of X that gives the minimized cost is 37 drones. So if they produce 37 drones, that'll minimize the cost. And that cost is $883. So if they manufacture 37 drones, it minimizes the average cost because that's the smallest Y value that we got. All right, and this is the end of 3.2. And you should be seeing 3.3 soon by the end of today.